Hello, today we're going to talk about glide reflections, which is just a continuation of what we've done with reflections so far, and finding lines of symmetry. Speaking of talking about things we've done so far, we have a new postulate right here, which looks a lot like one we saw in the last section. This postulate says that a reflection postulate is that a reflection is a rigid motion. If I reflect a figure, a point, a line, whatever, over some sort of line, it's going to preserve length and angle measure, just like translations did. So translations are rigid motions, so are reflections. If we look at this picture with the triangles here, the lengths of each side of the triangle have stayed the same. The angles have stayed the same as well. And because a reflection is a rigid motion, and we know that compositions of rigid motions make another rigid motion, if we do more than one reflection, that'll also be a rigid motion. If we combine reflections and translations, that's also a rigid motion. So, speaking of that, a glide reflection is where we have a translation followed by a reflection. It's kind of mapped out here. We start with the blue segment PQ. It is translated up to the red segment P prime Q prime, and then reflected in line K to get our final image Q P double prime Q double prime. So everything has been mapped from one the reflection to two, one the translation to two the reflection to get our final image. Let's practice doing some glide reflections ourselves. This should say after here, not after, so sorry about the typo there. They would like us to graph triangle ABC with these vertices, so let's go ahead and do that in Desmos. The usual, type in the coordinates exactly the way you see them and label them so you know what you're looking at. We've done this lots of times before. And make sure you don't make any typos like Mrs. Avers just did. So there is my pre-image triangle ABC. They want us to do our final image after the glide reflection. Always do your compositions in the order you see them. So first we are going to translate. This translation, I'm going to write what happens down here. It turns xy into x minus 12y. So like we've talked about before, we're going to subtract 12 from each x coordinate. Since y stays y, nothing happens to y. So a 3, 2 turns into 3 minus 12 since we're taking 12 away from x. And then 2, the y coordinate stays the same, which means that a prime 3 minus 12 is negative 9, and then 2 stays the same. Let's do that with the other 2 points. 6, 3 is b. I need to subtract 12 from the x coordinate, keep the y coordinate the same. So b prime becomes negative 6, 3. C is 7, 1. If I do that translation, I subtract 12 from 7. I keep the y coordinate the same. So C prime is negative 5, 1. Let's go ahead and graph those in Desmos. Again, label those. And don't forget your primes, so that way you know where you're at. Okay, we're not done yet though. We've done the translation. The other part we need to do is reflect in the x-axis. So think back to what we did in the last set of notes. When we reflect in the x-axis, AB turns into a negative b. So your x-coordinate stays the same, your y-coordinate becomes negative. So for A prime, if I'm going to do the reflection there, my x-coordinate stays the same, negative 9. My y-coordinate becomes negative or changes sign, so negative 2. B double prime, x-coordinate negative 6 stays the same. 3 becomes negative 3 for the y-coordinate. C double prime, x-coordinate negative 5 stays the same. 1 becomes negative 1 for the y-coordinate. So let's do our last bit of Desmosing here. We have negative 9, negative 2, label your A double prime, -6, -3 for B double prime, and -5, -1 for C double prime. So we started with triangle ABC. We translated, turned it into A prime, D prime, C prime, reflected it over the x-axis, or in the x-axis rather, to get our final image, A double prime, B double prime, C double prime. That's the results of our glide reflection. Let's try one more. It's the same starting triangle, so I'm going to keep A, B, and C in Desmos. I'm not going to type those in again, but I'm going to get rid of A primes, A double primes, and things like that. This time, our translation is xy turns into xy minus 6. So x stays the same. We subtract 6 from y. So A, 3, 2 turns into x coordinate stays the same, so 3. Y coordinate, we subtract 6. So A prime is going to be 3. 2 minus 6 is -4. Let's do that for the other points. For B, 6, 3, the x coordinate 6 will stay the same. And then I do 3 minus 6 for the y. So I end up for B prime 6, -3. C is 7, 1. So 7, the x coordinate stays the same. I subtract 6 from the y coordinate. So I get C prime 7, -5. Let's put those in Desmos. So 3, -4, A prime. 6, -3 is B prime. And 7, -5 is C prime. I'm not done yet though, I still need to do that reflection. This time we are reflecting in the y-axis. Reflections in the y-axis, I don't know why I just drew an arrow there. Turn the coordinates A, B into -A, B. So our x coordinate changes signs, our y coordinate stays the same. Let's do that to A prime, B prime, C prime. So A double prime, this x coordinate becomes negative. The y coordinate stays the same. B double prime, x coordinate becomes negative. Y coordinate stays the same. C double prime, x coordinate becomes negative. Y coordinate stays the same. So now let's graph those into Desmos. Make sure you label them this time with double primes because it's what we happened after 2 transformations. And last but not least, so then again, we can see what happened with our glide reflection. We started with A, B, C. We translated it down to A prime, B prime, C prime, and then reflected it in the y-axis to get A double prime, B double prime, C double prime. The last thing we're going to do here is look at lines of symmetry. You've probably talked about lines of symmetry before, maybe even as early as elementary school. In the more geometry, fancy math way of saying this, we say a figure in the plane has line symmetry when the figure can be mapped onto itself by reflection in the line. This line of reflection is our line of symmetry. What you've talked about this before, especially if you've learned this in elementary school, is what lines do I have a mirror image with? So what we're going to do today is just look at these polygons. Some of them are hexagons for the first 3, the rest of them are other types of polygons, and figure out how many lines of symmetry do we have. I think it's easiest if you just draw on it. So for letter A, and again, be nice about my drawing. My drawing is not as easy to do on the computer here. If I have a line of symmetry here, it is the same on both sides of that blue line. It is also the same on the both sides, if that line was straighter, of this line here. Any other way I slice it, it will not be the same on both sides. And so I have 2 lines of symmetry here. For this hexagon, I can go up and down through the middle, just like I did in the last one. I can go through the middle horizontally, like I did in the last one. But there's lots of other lines of symmetry too. Notice that the up and down line, the vertical line of symmetry, is halfway between two vertices. I have more of those if I go halfway between any other two vertices. I also, my horizontal line of symmetry goes in between, it goes through two opposite vertices. That is true for any other opposite vertices I have. That looks mildly terrifying, but you get the idea. So how many of these lines do we have? We have 1, 2, 3, 4, 5, 6. I stopped counting here because if I keep counting, I'm going to go back and double count lines I've already counted. So this has 6 line of symmetries. This last one is not a very common hexagon shape that we see. The only way that that is symmetric is if I draw a line through the middle there, pretend it's straight. And so I have 1 line of symmetry here. Let's do a few more. So for this rectangle, it's symmetric vertically through the middle and horizontally through the middle, and that's it. So it has 2 lines of symmetry. For this pentagon, symmetric here. Notice that goes through a vertex and halfway through an opposite side. And so that's going to be true for all of the other situations like that. How many of those lines did I draw? I drew 1, 2, 3, 4. I missed one. Oops. There should be one more right here. So let's count again. 1, 2, 3, 4, 5. I stopped counting here because otherwise I'm going to start double counting things I already counted. So there are 5 lines of symmetry for this one. Last one, triangle. The only way that this one is symmetric is through the middle vertically like this. So this one has 1 line of symmetry. That is it for today for glide reflections. Remember, glide reflection is a combination of a translation and a reflection. We can do those in Desmos like we've been doing. You'll need to think back to your rules about reflections, which are in your last set of notes. And lines of symmetry are where the image can map onto itself when you reflect within that line. That is it. Have a fantastic day.